Okay, so here we are in the code section of the video. I'm going to be going over the whole code that I'm using for the button box and just kind of showing you to the best of my ability what everything does, and to pass all of the knowledge I have on coding, such as it is, to you. So this isn't necessarily a tutorial for beginners. I have to assume just a little bit of knowledge of coding. If I was going to go over absolutely everything, I would. This video would probably be several hours long. So there are plenty of tutorials online for learning how to code, especially with Arduino specifically. There are lots and lots and lots of resources, so you'll have to do some research on your own. But I'll do my best to go over everything that I do here. So the first three things that we have, this whole section right here, are setting up the code for what it's going to be doing later. There are three major sections of this code. There's this sort of pre-setup section. I don't really know what to call it. Then there's this void setup section, which is all of this area right here. And then there is the void loop. I'm sorry, there's actually four major sections. So there's the loop that goes all the way to here. And then this section called void rotate. And I'll go over what each of these do in due time. So the first three things that I have here are # include, and then I have bounce, elapsed millis, and rotary. And these are called libraries. And they essentially sort of bring in a set of functions and things that you can add to your code that somebody else has already figured out. So somebody else has already figured out how to make rotary encoders work really well. And so I have taken this library from Ben Buxton, and I'll provide a link to his webpage, to his site in the description. But I've used his library for controlling the encoders. Elapsed millis, that stands for elapsed milliseconds, and that's I believe that's built into the Arduino software. And then there is bounce, and bounce is for when you press a button. Sometimes, a single button press can actually be read by the computer as multiple button presses, as it kind of flickers on and off. Debouncing is the process of kind of filtering all of that out and reading a single clean transition from no button press to a button press. So these three things kind of make your life a lot easier. And so in that vein, this whole section right here is setting up buttons for bouncing or for debouncing, actually. And so I'll go over this first one, bounce. So we're just kind of calling the bounce library, and then I've named the first key the first button as key on, which is the first flip of the switch, and then you say bounce and then what pin it is on, and then this is the duration of time, I believe, for the operation of the debouncing, and this is in milliseconds. And so 10 milliseconds works just fine for me, and then this is the same for every other button that I have. So the key start is on pin 1, and then so on and so forth, 8, 9, 10. This is mostly just sequential. And I was pretty lucky that the number of keys that the customer wanted added up, I think, exactly to the number of pins that the teensy has. So that worked out well. So I've just, I've taken the time to actually name each of these buttons, based on what they look like and what they do in real life, because it just makes your life a little easier. So then here we set up a variable, and this is from the elapsed milliseconds library. Time elapsed is just a variable that we're going to be using later for timing events. And then here are two unsigned integers, t interval and encoder interval. These are the lengths of time essentially that like a pulse is going to be sent when I use that. So to kind of demonstrate that, I guess I can pull up the game controller dialog in Windows. And so I'm going to flip the two-way latching switch. And that sets that, so you can see on button number 5, when I flip it, it sets that button to on for 200 milliseconds here in the T interval. That's how I define that. And the reason I do that is because if it wasn't this way, if I didn't do it the way I have now, essentially if I flip the switch on, that button would be held constantly on the joystick. And there's not really very many situations at all where you would want that in a video game controller. And then this encoder interval is when I'm using the dial for the encoder. That's how long like a single pulse is sent. You can see that right there on 24. That's only sent for 20 milliseconds. And that's so that you can turn the dial very quickly and it reads just a bunch of button presses. Boolean key start on. So this is a special type of variable that can only be true or false. And I'll go more in depth on what this does later when I get to the section where I actually program the key activator. And then these three things are all from this rotary library. And this is just defining each of the rotary encoders and what pins they're on. So I have 6, 7, 2, 3, and 4, 5. And so that's all for this whole setup section. And then we have this like actual section of the program called setup. This section of the program, as well as this part up here, they're only going to run once. And so these are things that just kind of need to happen once, and then the program knows that and then just uses that as it goes on. This section right here, attach interrupt. And so you can see that these are the same pins up here, 6, 7, 2, 3, 4, 5. This is telling the teensy to look for interrupts on these pins. And an interrupt is something that, like the name implies, it is something that is going to interrupt the normal programming and do something else. So in this case, for all of these pins, when it sees a change in the state of this pin, so when anything happens on this pin, it's going to call the rotate function, which I have down here. This function is called rotate. And so that just allows for very quick activation of the rotary encoders. So then we've just got one of those for each of the encoder pins. And then down here, pin mode 0 input pull up. So what this is doing is setting, these are all of the pins that have buttons on them. A button or a switch or anything except the dial of the encoder. And it is setting them to like a pull-up resistor mode, which means that each of the pins is normally reading high. And so what's actually happening is, let's say we've got, one of our buttons, and that's connected to a pin on the teensy. And so the pin is actually always reading a high value. These all of these logic states can either be high or low, or off or on, or what have you. So they're actually always all reading high. And so then when we press the button, it reads low. And unfortunately, I really don't know why that's the case. Maybe somebody in the comments can explain further, but that's just a kind of a standard that's been set up for projects like these, and just coding and electronic control in general. And so I've made sure to set the pin mode for all of the appropriate pins to this input pull-up mode. So that's all of our setup done. The void loop. This is the part of the program that just runs constantly over and over and over again. And so this section right here are all of the buttons that I set up earlier in the program. And this is basically just making sure that it is updating the state of all of those. It's constantly looking for the state of all of these buttons. And so this is where it's helpful, to actually have logically named keys and buttons and everything for what you're using. So this is the real kind of meat of the program. And I'm actually going to explain this not on the key first. I'm going to go to something a little simpler, just one of these buttons. So this is the first red button on the controller. And, it's pretty simple. It's either on or off. And that's what all of these buttons are going to do. All of the switches are going to do, in fact. So this first statement, there's kind of a pair of statements here for one button. So if the red button 1 sees a falling edge. So what that is, this is a little janky, but I'm going to do my best to kind of give you a little lesson in what this is. So imagine, we've got a signal coming from the board. We imagine this signal as a line, and it can either be a high signal or a low signal. So we're coming along, we've got a high signal. Remember, because we set the pull up mode, or the input mode, to pull up for all of these. So it starts off as a high value. And then we press the button, and the signal goes from high to low, and then it continues on. And so then this right here, this vertical line here, this happens in the space of just several milliseconds. So this line right here, the vertical line, is called a falling edge. And so here in our code, we're looking for this falling edge. And so the button is able to read that. The pin on the TNC is able to know when that happens. And when it does, everything that's inside this curly bracket will activate, which in our case is joystick button 6. And then the 6, 1, this is telling us turn on button 6, for button 6, turn it to on. And now conversely, we continue on with our signal here, and it goes from low to high. And that happens when you remove your finger from the button. It goes from a low to a high value. And just like the opposite of before, this is a rising edge. And so here, if red button 1, rising edge, so it's looking for that rising edge, and then it sets button 6 to 0. So it turns it off. So if we look here, 1, 2, 3, 4, 5, 6. So this is button 6 right here, right above the mouse. I don't know if you can hear me press that button, but you'll just have to trust me. It will stay active as long as I hold the button, and then when I release it, it deactivates. And that's all that's happening. This is the same programming for all of the push buttons that I have on the board. And so that's what this whole section is. And each one has the conditions that will turn the button on and the conditions that will turn the button off. And so that's it for the push buttons. And actually the buttons on the encoders work the same way, the exact same way. The encoders themselves, you can push them down, and they are a button press. And so this works exactly the same way, just different pins, different joystick buttons. So let's go on to the parking brake. So the parking brake, this is much different. Well, not much different, but it is significantly different from just a normal push button, because the push buttons will return to their normal state when I release them. But a switch doesn't really have a normal state, because it will stay in either position when I push it there. And so this is what I was talking about when I was demonstrating the switch. Every time I flip it, it pulses for 200 milliseconds. So a fifth of a second. And so this is how it does that. So it's looking for the falling edge on the parking brake. And in fact, it's looking for both the falling edge and the rising edge. And when that happens, in both cases, it's going to set joystick button to 1. So it's going to activate it whether or not it's flipping from up to down or down to up. But there's an additional command, there's an additional line of code inside the if statement that sets this time elapsed variable to 0. And that's something we defined earlier. And so essentially, whenever you see this line of code, think of it like you're starting a kitchen timer. And in this case, the kitchen timer is going to be running for 200 milliseconds. And so this third section, in this little section of code, when time elapsed is greater than t interval. So this t interval is just that, it's all it is a number for what we set earlier on, which is 200 milliseconds. And so when 200 milliseconds has passed, time elapsed, so the timer gets past 200 milliseconds. And when that happens, it sets this joystick button to 0. And that's it. It's as simple as that. So it's, you flip the switch, it starts timing, it's looking at the stopwatch, and then when it gets to 200 milliseconds, it turns that button off. And so this is the same as each of the LED switches. There's no difference. The only difference is the name of the switch, of the button, and then what joystick button it is activating. And so you can see for each of these, it is looking for a falling edge or a rising edge. And people, some of you sharp viewers might notice that there's a way to make this code a lot more efficient. If you know what that is, leave it in the comments below. You are much smarter than I am. But I'm not going to change anything because I'm too afraid to mess with it. I can't code with people watching. So a little difference here is all of these if statements are done first. And then there's this big chunk of code that is just waiting for the timer to reach 200 milliseconds. And then it just turns all of them off. There's really, really rarely any situation where you'd be like pushing like 2 switches on at the same time where they would interfere with each other like that. And even if they did, the games and your computer can typically read pulses much smaller than 200 milliseconds. So that's plenty of time to allow for any sort of interruptions or things like that. So now something a little bit more complicated, how the key starter works. So we'll just go through it one at a time. So if key on, falling edge. So the pin that is connected to the first position of the key. If it's not obvious, the key has 3 positions. The first 2 will latch and stay at whatever position I set them on. But the third, when I turn it even further clockwise, is momentary. So it will stay in that position only when I'm holding it, and when I release it, it goes back to the first position, or excuse me, the middle position. And so that's, to replicate the feel of an actual car where it has an off state and then an on state where the battery is on and the radio and the AC comes on and everything. And then you hold it for a certain amount of time to turn the engine on, because you don't want the starter motor to just be running and running and running. You just want it to turn on momentarily to turn on the engine. And then it goes back to the on state. So here we've got key on, falling edge. So it's looking for the point where the key moves from off to on. So from the off position to the on position. And when that happens, turn on joystick button 1 and set that timer. So that works the exact same way as the toggle switches, because in fact the first 2 positions of the key are a toggle switch, essentially. And so then this next section, this is where it starts to get different. The key start, falling edge. So this is when we go from the on position to the start position. And so that also turns on joystick button 1. And it also sets this variable to be true. This is the Boolean variable that we set earlier in the code. This is necessary for a reason that I'll get to at the end of this section. So, we start in the off position. It detects the falling edge for when we go to the on position. It turns on button 1, starts the timer. And if we were to stop here, button 1 would stay on for 200 milliseconds and then turn off. But then when we continue on to the start position, we can see that it's going to keep button 1 on for as long as we have that held. And in fact, let me give you a little demo here. So this is button 1. Oops, so that was just moving it from on to off. So it's in the off position now. And then I turn it to the on position and it pulses. But then I can turn it to the start and it stays on as long as I hold it. And then when I release it, it stops immediately. And then when I move it back to the off position, it pulses again. So continuing on, the key start rising edge. So this is what happens when you move from the start position to the on position. It turns this variable off, and then sets the joystick button 1 to 0. It turns it off. And then once again, when we get the key on rising position, it sets the timer to 0, and then sets the joystick button 1 to on. And then this final line of code, this is what allows us to keep the key or keep the button held on for as long as we have the key in the start position. The timer is only going to turn off the button if key start on is also false. So you can see here, key start on is going to be true for as long as we hold the key in the start position. It's only going to turn off when we move the key from the start position to the on position. So that means that the timer is not going to turn off the button until I release the key. So as long as I hold the key on, it's essentially overriding the timer. And so the reason that we do this, that I've done this, is because This is specifically for Euro Truck Sim, which kind of makes this button box a little problematic to use for other games. But it can be largely ignored if you just don't press the start button, or if you don't turn the key to the start position. In Euro Truck, you can turn on a setting to where you press a button to turn on your truck, and pressing it once turns on the batteries and the battery and the electronics and all that, and then pressing it again turns the engine on, and then pressing it once again turns the it turns the engine off, and then pressing it a final time turns all the electronics off. And so we can do that here programmatically. So the key is off right now. Then we flip it to the on position. It sends a pulse. And so that has turned on the battery and whatnot for the truck. And then we hold the start position, and that's starting the engine. And we can do this for as long as we want, and then release the key, and it turns off. And so at this point, we've got the key in the on position, and the engine is started, and we're all good. And then as soon as we turn the key off, I realize I explained that wrong earlier, but as soon as we turn the key off there, then the truck shuts off. Now, I've gotten this to work in Elite simply by only using the off and the on position, and just kind of ignoring the fact that there's a third position to this switch. So that's probably one of the more complicated parts of the code. So if you understood that, you'll understand everything else. And I realize this video is getting long, so I'm going to go quick. The shifter is a 3-position switch. And once again, this is specifically for Euro Truck Sim. It's looking for the falling edge for shift up. So this is detecting when the switch moves up. When it does that, starts a timer, turns on button 2 on the joystick. It's pretty straightforward. On the falling edge, so when the switch moves down, starts a timer and turns on button 3. And then, if shift down rising edge or shift up rising edge. So this detects when the switch moves to the center from either direction. So whether we start at the top and go to the middle, or starting at the bottom and move to the middle, it's going to set a third button, well, the 4th joystick button, it's going to set that active and start the timer. And then for all of these, it's going to turn all 3 of these buttons off after the interval. So a little demo here. So we're looking at buttons 2, 3, and 4. My shifter is in the middle position. When I push it up, it turns on button 2. When I go back to the middle, it turns on button 4. When I go down, it turns on button 3. And when I go back up, it sets it to button 4 again. And so the reason for that is in Euro Truck Sim, we can set button 4 to be switch to neutral. And then the customer uses, I believe it's called Simple Automatic in the game, where you basically switch between forward, neutral, and reverse. And so this switch is sort of a fake gear shifter. And so we set the upward button, so button 2, to be shift forward. And then when you bring the key back, when you bring the switch back to the middle, it sets it to neutral. And then when you go down, that button press, number 3, sets the truck into reverse. And so that's another thing that was specifically made for Euro Truck Sim. However, I have also been able to use that in Elite, where I will set the upward position to be 100% throttle, and the middle position to 50% throttle, and the downward position to 0% throttle. We already talked about the parking brake switch. The LED switches all work the same. Encoder buttons, they're the exact same as the regular red push buttons. Looking for a falling edge, turns the joystick button 17 on. And then on the rising edge, it sets joystick button 17 to 0. So the final section is void rotate. And so this is how it handles all of the encounters. Sorry, excuse me. All of the encoders. And I want to say a big thanks to Ben Buxton once again. I don't think this project would have worked nearly as well without his encoder library. So I really encourage you to go to his website, link in the description, to read up more on how these encoders work. Because I can't explain them as well, to the same quality that I've explained everything else. This section consists of these three kind of subsections, and they're all functionally identical. They just use different button presses. So we have this section, this line right here. I really can't break it down into individual elements. I just know that this is how it works. I use this from an example from Ben's website. So it's reading, essentially it is reading what is happening in the first rotary encoder. And rotary 1 is what we defined earlier in the code up here, rotary 1. So it's reading what happens and then writing that to a variable called result 1. And so then, depending on what happens with this result, one of two things is going to happen. If the result is a clockwise direction, so if you move that encoder clockwise, this is what it's going to do. And conversely, if you move it counterclockwise, this is what it's going to do. And so past this point, it's all stuff we've seen before. Time elapsed gets set to 0. It turns the encoder, it turns that input on for, I believe, 20 milliseconds. And I've added something here. It turns joystick button 20 on and turns joystick button 21 off. And so it does that specifically to kind of reduce the chances of any opposite inputs happening. Sometimes the encoders will get stuck between two inputs. They kind of, there are like physical indentations that that the encoder will kind of sit at when you're rotating it. So it's kind of like chunk, 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 rotating like that. And so this makes sure that only one joystick outcome happens from the result of a rotation. So turns on the timer, turns joystick button 20 on, and turns joystick button 21 off. And then if you turn it clockwise, the reverse happens. 21 turns on and 20 turns off. And so when I spin the encoders, now I think what's happening here is that the timer, the time for the pulse to be on for the encoder is so low that sometimes this dialog can't read it. I'm not terribly concerned about that because it seems to work just fine in games. But you can see that, when I turn the encoder left, 20 is turning on. And when I turn it right, 21 is turning on. And then when I push it in, that's just an entirely different button. And so with that, it's the same thing for the other two encoders. And that completes everything about the code for the program. Now, I can't guarantee, obviously, that this code is going to work for you, but I hope that I've given you enough knowledge of how this works to be able to build one yourself. Just, this is exactly what I did, looking at examples of other code. I didn't have the luxury of a step-by-step explanation of what everything did, but I was able to figure it all out through experimentation. And I believe that you can do it too. So If you have any questions, drop me a comment here, message me on Reddit or on Twitter, and I will do my best to help you out with anything. I hope I've done a decent enough job explaining all of this to you. And I think we'll go to the end of the video and show you the final product.